It is February 17th, 2015. Delegates and scientists from 30 nations have gathered in Nabat, Morocco, hours after intelligence agencies received information about a stolen nuclear device with possible intent to use it there. The international team has barely assembled when they received the first blood-curdling reports that a low-yield nuclear device has just been detonated in Casablanca, a nearby city of over 3 million. Simulated events like these is something that the United States Domestic Nuclear Detection Office participates in regularly with international partners in an effort to make sure that these scenarios do not become reality. The DNDO's front line of defense against nuclear terrorism is screening all people and cargo in all major entries to the U.S. by land, air, and sea using radiation portal monitors. Radiation portal monitors look a lot like a highway toll booth, except that instead of giving people or baskets money, there are box-like radiation detectors. These radiation detectors can sense radiation from nuclear materials inside the cargo and use those signals to figure out what the radiation producing material is inside of the cargo. Sometimes a smuggler can attempt to make this more difficult by blocking radiation with some sort of a radiation shield. But a faint signal will always get through. The challenge is to use these faint and sometimes altered radiation signals to figure out what nuclear material is in the cargo. This requires innovative math and computational techniques. My research pushes the cutting edge of what these math and computational techniques are for calculations like these. Other applications of my research include nuclear energy, making it cheaper and safer, new technologies like fusion, potentially for energy usage, and ensuring that the United States nuclear arsenal, which is aging, is still able to perform when we want, where we want, but in no other way. Last year, the DNDO screened over 600 million containers entering the U.S. to help protect us from the threat of nuclear terrorism. The equipment is getting old, and the current methods are rife with false alarms, causing inefficiency and a lack of trust in the detectors. My theory and methods-based research helps to improve these types of calculations, making nuclear forensics equipment and other applications more reliable, helping provide us with a safer tomorrow, and, in fact, a tomorrow.